wrote the talks on guidebook, both the mobile application and the website. So after you've seen something, you can just cast your vote. Then I should remember that there is the Google Code Jam tonight, and if you want to attend, you should register on the EuroPython website. Okay? So, let's welcome Adam, and let's see how DISQUS does it. Okay? Thank you.
My name's Adam. Thank you for having me in Italy. It's great here. And I'm going to talk about kind of DISQUS's emerging applications. What are we doing when it's not Django? Because Django is most of what we do. But there's kind of this growing gap. So first, common misconception. Boom. So yeah, it is called DISQUS, and most of you have that right now. It's been a long year trying to get people to say it correctly. And I'm going to just say this up front. If you think this is interesting and you want to live in San Francisco, talk to me. We do interesting stuff all the time. So quick audience participation. If I ask you to raise your hands, how many of you will raise your hands? Okay, that's like the best participation rate ever. How many of you have heard of DISQUS before? Like everyone. How many people knew it was DISQUS and not DISQUS? It's like, okay. Most of you know. Okay, excellent. So yeah, so for like the 4 people that didn't raise their hands, DISQUS is a community platform. So our product, it is, as consumers see it, a JavaScript embed. You like put a line of JavaScript on your web page. It's super simple, and you get comments. And lots of web pages use us. Lots of big websites use us. Publishers like CNN, and then lots of very small publishers like my blog. It's very small, and we're kind of big. So this is from the last 30 days. We had 7.1 billion page views, apparently, with 1 billion unique visitors. And like we're rounding off, saying 1 billion with 79 million, just be like, hey, screw them. No, but and lots of people visiting our website. So our system is like small problems for us are big problems, because all problems are big problems at scale. So just to illustrate what our scale looks like. So this is when Pope Francis was announced. And so you kind of have a normal news day coming up to the Pope Francis announcement. And then boom, the internet went crazy. But this kind of pales in comparison to what happened when the Boston Marathon occurred. So the purple line at the bottom is when Francis was announced, and then the green lines are when so it was a really busy news week actually. So we had the Boston Marathon, we had ricin letters sent to Senator and the President, then there's like this giant explosion in Waco, and then there's like this manhunt that goes on. This last spike I think is super interesting because that's 2 a.m. Pacific time. So this is an American news story, and so America was asleep, and that's how much traffic we were getting. And the top of this graph is at 5 gigabits, and the reason the graph stops there is that's how fat the network pipe is. So we fixed that. But yeah, so we get interesting traffic. So again, I'm here to talk about what kind of makes up DISQUS, and there's a couple of answers to this. So we use multiple languages. We have the applications we produce. One of them is way bigger than all the others. Then there's kind of also like how we get work done, and then there's the new stuff that I mentioned. What's that emerging services stuff? So it's mostly Python. There's JavaScript too, but this is a Python conference, so we're just going to say mostly Python. And we love Python a lot. Why? Why do we love Python? Probably many of the same reasons you do. It's super fast to get work done in. Lots of people like to argue about the actual speed, and I don't actually care because I get so much work done because I'm working in Python. It's got this awesome community. Everyone in this room today is evidence of that. There's tons of libraries that everyone in this room is making and sharing, and it's a super active community. It's so active that we can't keep up with the language. Just audience participation. Who's on the latest version of Python in production? Just anyone running? Okay, it's like 2 people. But we're all going to be there someday. DISQUS is just finishing its transition to 2.7. And that's exciting because I get to use dictionary comprehensions. Love those. The other thing about Python is we've got 6 years of practice in it. So we have a really great development loop. But what else makes it up? It's pretty much this huge, 3 U's and huge Django app. So that's a pain sometimes just because it's so much code. But only sometimes. And the sometimes is because we've got really great practice at it. So what does that look like for us? We use a tool out of Facebook called Fabricator to manage our development cycle. So you write code. So step 1, you should already have the code. Step 2, you're going to write some new code, and you submit a diff. Goes through our code review process. In our code review process, Jenkins will actually, before you ever commit any code in Git, it will take that and it will run it against master, and Jenkins might say, no, Adam, you write bad code. No tests, I'm rejecting it, or whatever. Once it's actually good, you get to use Git and you push it. And then you wait. So this waiting part is we roll up our commits in a daily deploy. Sometimes we do 8 deploys a day. Sometimes we do 0 on bad days. But eventually we're going to be auto-deploying, and hopefully I'll talk more about that later. But that's kind of how, for our monolithic app, it works. What else makes up DISQUS? We kind of have this emerging services architecture. So, 2 years ago, we were basically all Django, and today it's 70% Django. I totally made those numbers up. But I think that they're kind of accurate. And it depends on how you cut it. Are you looking at data transferred? Then it's 50-50. Are you looking at lines of code? Then maybe it's 80-20, I don't know. But it's a growing gap. And so we'll examine what is that gap in a minute. But the first question is, why have a gap? Why not just add more code to that thing that's already got all the code in it? Well, it has a couple pain points. So the top line is not a pain point. It's just the stack we use, and it's an awesome stack. How many people here use a really similar stack of Django and Postgres or something else? And so, yeah, excellent, half the room. So it's great. So pain points. 1, we roll up commits to deploy them. So that's really great because your code gets committed by someone else, or it gets pushed by someone else, and I don't really have to care about deploying. I like to care about writing code. I'm not the ops guy. Someone else's problem. But what is my problem is when my code doesn't ship because not me, totally someone else accidentally includes pdb.setTrace. That was definitely not me at all. And that ends up bringing the entire website down because and reverting 7 other people's work. So I was going to be an awesome scientist. I was going to do A/B testing, we're all told is a great thing. But now I've got to wait another day to get my code out, and that ultimately is affecting revenue of the business because my experiment was going to make us millions of dollars. It was going to be great. So because of problems like that, including bad code, we have very high scrutiny code review. So sometimes it's too high scrutiny. You're no, I really need this code in. Can we stop arguing about it? So finding ways to reduce that would be awesome. And then that is also a problem because we have a lot of code going into the system. We have 18 engineers at DISQUS right now. and only about 6 to 10 of them are really good at reviewing Python code. So a small group of us are reviewing a lot of code. And so the round trip there can just be like 24 hours. I'm just trying to get people to say, hey, do you even think my code is good? And the biggest factor, again, is a huge app. So there's like API 1.0 and 2.0 and 3.0, and like, why do we have all these deprecated versions of code still in the code? We still have to work around those. So that's just really annoying. So problems that don't fit in that monolithic app are, one is a technology problem. It's sometimes we have super high concurrency systems, and those just don't fit in our implementation, or the way that we're running this Django Postgres thing. Sometimes you want to isolate things. You want to protect that monolithic app. If that thing crashes, you can't do any other things because the embed, those comments aren't loading. So you can't put ads on comments that aren't there. So making sure that is secure is good. But you also want to isolate features because you don't want that slow development loop. You want your own fast little loop. So you're isolating yourself from that process as well. And also fun, because like experimentation is great, and sometimes just like, what's this new library? I want to play with it. So it's super awesome to have flexibility for fun. So what did we start with playing around with? So for that fun and concurrency area, these are just 3 things that I'm going to give links to them. But again, this is a Python conference, and none of those are Python. So the top one is Nginx modules. We basically started replacing giant swaths of code with Nginx modules, like thousands and thousands of lines of code. And that's just because someone else did the work, and someone else is maintaining the work. If you've seen me talk about real-time, one of my real-time talks was how my ops guy replaced my entire real-time system with a single Nginx module. So that's specifically what that talk is. But we liked Nginx. It was great. It's super fast, and it's super high concurrency. So we also started playing with Lua. How many people know what Lua is? Oh my god, like everyone. You guys are great. So Lua, it's a scripting language. It's pretty old, but it didn't have super high traction. It's really popular, like to make video games. Like World of Warcraft is basically all Lua. Anyway, so it's awesome because it's also highly embeddable. So for whatever reason, some crazy Russians decide, let's put Lua in Nginx. This could be awesome. And now you can put just embedded code in Nginx, and mind-blowing. And you can actually, some other crazy people said, I want to do the exact same thing in my database. So now you can also run Lua in Redis, and this is also mind-blowing. But you can do crazy things that are bad and crazy things that are good with it. So we started playing with that. And then also Go. So again, I mentioned my real-time talk. Another giant swath of that code was replaced by a Go program recently because it was almost a victim of its own success. We started a real-time system only dealing 200 events a second, and a couple months ago it was in those CNN, or in the graphs I was showing earlier, it was 10,000 events a second. And we could have scaled the Python one out, but we said, hey, we want to try something new. And we said, let's try and replace some of it with Go. And it's working awesome. So play with that. This is just real live production code. This is how we replace several hundred lines of Python, I think, with this. This is basically hitting the Embedly API to get a URL for a thumbnail, and then serving that URL. And this just runs in process in Nginx. Every single request gets its own little thread. And it's super simple until you have to update it. Because, again, we have this awesome Python development loop. So things like this are sometimes also a little bit one-off for us because it's not in our daily development cycle. But Python still works great and has really awesome use cases. So specifically for isolation and iteration speed. So failure should be isolated. But I also kind of see a converse of that. It's when you're isolating from other things, you're also you're not blocking on waiting for other people to have their own little successes. So I want to be able to make $1 million for my company without having to wait for the other guy sitting next to me to make $1 million for my company. So I really like isolation as a two-way street. So we did several things because we like Python services. We've written a script that runs in cron, and it's just like, hey, if main, do stuff. We've written basically 10-line WSGI servers that are just using WSGI refs and simple server. We've written XML RPC servers, and they're all awesome and working great the first time. And then you have to update it. And the problem is some guy just SSH'd into a server and put it there. So how do I update that? I don't even know where it's running. So we kind of learned that things like consistency are really great. Protects you from exactly what I said, like someone SSHing in, running a script that's mission critical, and then quitting. Simplicity is great because it's easy to understand. I can give it to interns. Modularity is great because then we can share code. But copy pasta is not modularity. It's bad. And then bugging ops for a deploy and not having to do that is like the best because they don't like me. So what do? We wrote this thing called DISQUS service. So DISQUS service is a library to solve these problems. Consistent/free access to configuration, to application level switching, for rolling out features, for experimentation, system-wide logging, access to our graphite system, access to also error reporting. So basically, everything should be configured by default and free. And we really focus on convention over configuration. You don't want to have to deploy like 15 files if you're doing just one thing. You should be able to deploy just one file. So, and above all, it should be easy to run. So what is it? It's a decorator. That's it. Now you can run it. So what's that look like? Well, you import the service decorator, and you decorate your function, and then toil is the command line tool. It's kind of like manage.py in Django. It does all the things. So toil run hello.world, and it will print it out. So this is pretending this is in the hello module. So you basically just run the module path, or the path to the object. So it's a callable. So so that's the whole DISQUS service thing there. But sometimes you're like, that's really not enough, Adam. I'm special. I have my own unique requirements, and I really need to get in low level to this service thing. So in that case, you can actually subclass service, and then you get all this other functionality, which you have no idea what those words mean. They mean these. So a service kind of has a life cycle. You see, I see most programs as having life cycle. I see data as having a life cycle. So looking at service life cycle was natural to me. The life cycle is first you're going to config the thing, and then you're going to run the setup on the thing, and then you're actually going to run your code. So the config, you get two hooks. You get a pre-config and a post-config, and then that middle step, that's magic. You don't have to care about that. And then the setup is the exact same thing. You don't have to care about that middle step. And then the run, you just have to care that the handler method is going to decorate what's basically the main method of your service. So the cool thing about that self-config, what's it going to do? It's going to look at local files. It's going to look at environment variables. It's going to talk to the Zookeeper and Redis and anywhere else you could imaginably put information. It's going to glob it all together and figure out, well, what is actually the config that this service needs to run with. And so having that as a step really just eliminated a lot of copy-paste code right off the bat, because that's what most of these services that were one-offs were doing. It was just like trying to do their own way of setting up logging, setting up config, setting up Zookeeper. So what does this Hello World 2.0 look like? Well, we import the service. We have this post config step where we're going to set up Redis, because who doesn't love Redis? And then this handler decorator is going to look over, or it's going to say this world method is what should be called when we actually do that toil run hello.world again. And the result of this would be it's going to go to Redis, it's going to get whatever's in the hello world key, and it's going to print it out. So I found that I was kind of doing a lot of repetitive work when making services. So we kind of built these helpers. We found often we're making Flask services. I personally like communicating over queues. I think data streams are the way to go. So there's a service that there's a mixin that allows these services to talk over varying queue infrastructures. I love gEvent, and so I have lots of helpers for that. Pre-config for Redis, pre-config for other systems that we use at DISQUS like Kafka and the Django ORM. So this is real-life DISQUS code. It's basically a debug service. You're going to be able to do toil run shell, and it's going to give me a shell with Redis access to one of my production systems, and that system is called Tempest. And Tempest is the code name for the ad server. It's not code name, it's just the name. The name for the ad server that I'm working on. So this is like real live DISQUS code, but it's just kind of debug code. And, but it works great. So I want to kind of talk about, so I've said kind of how we write services. I want to talk like why would you use services ever instead of the monolithic app more. So this is kind of how that Tempest service grew. Step one was, we put it up in the corner in that monolithic app. It was part of it. It was great. It was making money. And it crashed a lot. And that took down the rest of everything else in that box. So we came up with this idea for a new ad server where we didn't have to involve the old thing at all. It was an awesome idea. And it's basically a background task that's going to put stuff in Redis, and then we've got this web server, and it's going to talk to Redis and serve out requests super fast, because Redis is pretty fast, especially when you're just reading from it. So what is this? So this background thing has like a couple phases. And that thing on the left is just basically a Flask server. So those phases, one of them is going to warm up Redis. So it's basically a fetch data from all over all our data services and get it together. Then we're going to remove bad data. Then we're going to score ads, because that's what you do with ads. You want to show good ones, not bad ones. And then we post-filter those ads, so there's still bad data somehow. And then we put it back in Redis for that web server to use. So I had my intuitions when I was going about this architecture on what was going to be fast and slow, and I was only like 50% correct. So when looking at services, it's really important to not prematurely optimize. We started by putting it in our monolithic app, and it wasn't until it was having problems we moved it out. So we moved it out into one service to start. It was actually called do all of it, was the name of the method, and that did the 5 things. And it still has that setup Redis thing. What we ended up finding out, though, is that I thought the whole thing was going to run in like 4 seconds or something. But it turns out that one stage was really slow, and it took like 10 minutes, because apparently it was a lot of data. So what we decided to do was break it out into more services, of course. So we split up the warmer and that pre-filter into one. The scorer, the post filter, and the pusher are 2 more services that, so each of those boxes is a service now. And that line there is a queue. So now it looks kind of like this. So I have this Redis helper, and everything's going to use it. I still have old faithfuls, because even though it's slow, I know it works. So when I'm writing code, I really try to roll forward in a way where I'm not prematurely deleting services, because you're going to have a bad time when your new thing doesn't work, because new things like never work the first time. So these are what those 3 new services look like. Basically just broke out that one Tempest service. You'll see this new queue service and this new decorator on message. On message is super cool. What it does is it listens to a queue, and then whenever it sees a message on the queue, it calls that method. And so it's another thing that's awesome. It just completely abstracts all. It's kind of like Celery, actually, but does less. So what actually runs now? Well, we could run a lot of those warmer processes because they're super slow, and then we run a couple of these other ones on separate machines for redundancy, because redundancy is great. You don't want to crash because hardware fails. So that's basically how we scaled out that Tempest service initially. And the key lessons there are just do not prematurely optimize until you measure data, because you're probably wrong, because your intuitions are what you want to do, not what data actually says you should do. Yeah. So one thing that I kind of found when I was writing this is that I thought that the trick that is used for those decorators and how to do hooks in a class like that was kind of cool. And it wasn't my idea. I stole it from someone that sits next to me at work. And his name is Jeff. He goes by nflux on Twitter. And so the stuff I use in DISQUS service is literally the exact same code as this other library called exam. And exam is super awesome. It helps you write tests way better by getting code out of tests into fixtures. So if you want to see this code like right now, you can see it at that GitHub repo, line 35, that file. So this is what the decorator looks like. It's basically, it's an object that when you, or it's a class that when you decorate a method with a class, it's just going to save that the thing you're decorating inside that class. And then you can see the postconfig hook, or the postconfig decorator. It has no code. It's just subclassing that thing. So all of those decorators are just the one-line pass classes, subclassing base. And then in my base service, we have these 2 scary functions. You know it's really scary because it has this line, it's like the 3rd line, inspect.getMRO. And whenever I see MRO, I'm like, no, I don't want to do that. But this is a cool use of it. So basically, the adders of type is going to, given a type, find all attributes on a class of that type. So the way that this works is you decorate a method with a decorator. You say get adders of type, and then you pass in for that kind value what is the decorator, just the class name, not the name, the class itself, and it's going to give you all the methods that have been decorated with that. And then the run hooks part is if you pass in the decorator for that hook value, it's just going to, as a list comprehension, get all those attributes and then execute them. So this is kind of what that looks like. So for the call method in the service, services, the classes themselves are callable. It's going to say self.runHooks with the handler decorator. Another awesome thing is that, how many of you know what context manager decorator is? Like most of you? Yeah, it's my favorite decorator because it's super, super simple context manager. So it's from context lib, import context manager. And the thing above the yield statement is your dunder start method. And the thing below the yield statement is your dunder exit method. So it's just stupid simple, and it makes context manager so much fun. So yeah, so this around config is going to run the pre-config and the post-config as a context manager. So you can say with around config, self.config, and it will do the pre-config and post-config. So that's how those decorators work. I just think it's a super cool little trick, especially if you can just copy it from someone else. So yeah. So I've mentioned mixins a couple times, and I actually got into a fight with one of my former coworkers last night about mixins because he said, they're the worst thing ever, you should never use them. And I was like, but David, my entire talk is about how they're great. And so I kind of say with great mixins or with great power comes great responsibility. What is a mixin and what is just multiple inheritance? So they're the exact same thing in Python, except multiple inheritance is when you are taking classes that don't know anything about each other and squashing them all together. And mixins are when you're taking these really nicely designed cooperative classes that were designed with each other in mind and squashing them together. So I just kind of want to go over like what's a real, like, this is my argument for mixins as a straw man. It's a super simple data pipeline. It's got 3 phases. It's got a parse phase, a compute phase, and a publish. Don't run this code, by the way. I don't think it will work. Or any of my code in this talk. Anyway, so it's got this compute, publish, or parse, compute, publish, and then you see this pipe data method at the bottom. That's kind of what we use to put data in. And it's going to call those 3 phases. So it's going to do this. Get the parse data, get the compute data. It's going to chain in the data from the previous method, and it's going to publish the data and return that, because why not? So what mixins for this look like? Well, mixins would do exactly one thing. If your mixin's doing more than one thing, you're probably doing it wrong. So you see I've got a couple of mixins here. JSON parser, because who doesn't love JSON, and I hate XML, so JSON parser. In case some sort of nefarious government agency might be listening in on your conversation, I have this super secure ROT13 based parser, or encrypt data mixin. That's what it's doing. This is for the compute phase. Sometimes you're just really paranoid and you just want to like anonymize your data. So just return an empty dictionary, and then sometimes, you know, where do you want? You got to do something with this data, right? There's no point in parsing data if you're not publishing it somewhere. So maybe to the web, maybe to a file as append. A is append in files. That took me a long time to learn, but it's great. So what would a file pipeline here look like? Well, you can just kind of smush them together. Notice none of these ever have the same stage twice, because that will screw you up. I think that it actually might raise an MRO error, or MRO exception, and if you're getting those in your code, you're doing it wrong. So this is just, you can mix and match these. But what about testing? Because that looks a little complicated. Like, how do I test this? Because it just says pass. Did testing these test those? And the answer is no. But you can mix your tests together as well. So if you're testing each of these well, because you're doing good test-driven or behavior-driven or whatever, however you drive tests, like after I wrote the code-driven, you can, so basically, you know, you only have to test one thing each of these. It's a super simple test. It's like, did it return an empty dict? Well, you can basically write test stubs for all of these and mix those together as well. So when you end up having your production code that looks like this, your test code also looks like this. And the reason I like this is each of these is super simple to reason about. And because these are all super simple to reason about, these kind of inherit that. You're like, oh, I see, it does exactly these 3 things. I just have to go look at them. It requires that you know what the pipeline is doing, though. You have to know what your mixins are cooperating to do. So for this reason, I kind of think that they're really great for your internal APIs, for your internal code. They're really bad for a public API. So if you look at Django, Django kind of has mixins. They have like apps that you can install, but they do not choose to mix a whole bunch of classes together as inheritance, because people do crazy things with your API once it's public. So they have a list of modules that it loads and runs like initializations on. So I just think this is really great because it's simple and it's short, and yeah. So that was why I like mixins. So DISQUS loves to open source things. Things that have come out of DISQUS include Sentry, which was written by the guy I was arguing with. It's its own company now. Nidus is awesome. It is this thing that lets you round robin or consistent hash to a Redis ring. Do you send emails from Django? You have Django mail views to solve that. They're super pretty. Gargoyle is, how many people use Gargoyle, out of curiosity? No one. It's great because you can say like, if switch. How many people know what application switches are? Okay, I've been saying this word a lot. I'm going to talk about it for a sec. So an application switch is basically, you've got Postgres or Zookeeper or something storing some data, and you say, if I set a Boolean in my ephemeral data store, do one code path, otherwise do the other code path. So it's really, you can say, if I'm in A of A/B test, do A. Otherwise, do B. And so switches are really great for that. It's really great for, you know, when Google rolls out a new email feature, but you don't have it yet, and you're like cursing the world because you really want that special inbox. That's behind a switch, and it's rolling out. So Gargoyle is just, you should use switches. They're awesome for production apps. Gargoyle is a system that does that, and many, many other things. What about DISQUS service? Well, it's not open source yet. I really want it to be open source by today, but it's not quite ready. It's going through like security reviews and stuff. So, but I really want your feedback. Would you actually use it? How did you solve the same problem if you have the same problem? And was my way stupid, or was it the best way ever? So just a quick summary, what did I just talk about? So we love Python, but sometimes there are other tools that are right for the job. Services are awesome, but services are really great for scaling. You need to grow into them, I think. Let's see. We talked about some cool decorator hacks, and mixins are the best or the worst, depending on your perspective, but I think they make testing easy. Again, if you want to move to San Francisco, come talk to me. And then I have some questions for you, because I don't have all the answers. So just, how do you guys run services? Just come find me later. I really want to know about this because I care a lot about it. How do you guys have services talk to each other? So do you just use HTTP? Do you use queues? Do you use thrift? Like what? There's a million ways. What do you guys use for super highly concurrent things? I'm using Nginx and uWSGI now for like front-end high concurrency, but what do you guys use for back-end high concurrency? Does anyone do anything to make sure pdb.settrace does not make it into production? And if you do, can I have that script? Please. And then the other thing I've been thinking about a lot recently is, does dev equal production or does it not? So when you're developing code, I've definitely had bugs that happened because we were running like flask.run server locally, and we were running uWSGI on production. So now I just run uWSGI locally, but it's like not good at auto reloading. You can write scripts, but it's not as good for development. So just like, what do you guys do there? So that's my whole talk, and I'm going to leave you with these questions, and please feel free to ask questions of me or answer these questions in front of the whole audience. So thank you very much.
So thank you, and there are already people wanting to answer your question.
Yeah, please answer.
There are a lot of people, so I will just pick somebody at random. I don't know. Got quite a lot of time, so.
Yeah, it's not quite a question. It's an answer about the PDB set trace.
Yeah.
Basically, what we do, we add a commit script that prevent people to commit at all PDB set trace.
So like a git hook?
Well, we did it in Mercurial and
okay, sure.
and Subversion, so I guess you can do it in Git as well.
Cool, yeah. I like that answer actually, but so the answer was basically a post-commit hook. With post-commit hooks is you have to make everyone use post-commit hooks, and I prefer things that are not optional.
We did that on the main server, so you can basically you cannot push anything that has a PDB, and hopefully enough, if you have a PDB, you can make a new commit, and it will just be gone of the diff, and you can push to the main server.
Right. So great talk, by the way. Thank you very much. Very insightful. One thing that maybe you can talk a little bit about is how do you, what clients do you use to talk to services internally? Because from what we've seen, and we run a large service-oriented architecture, is that there isn't a lot of that stuff that basically, I guess, Netflix does and talks about everywhere.
Yeah,
and basically being rebuilding these, and it would be great if we could open source this stuff or team up or something.
Yeah, so excellent. So that sounds like one person might actually use it. How many people would actually like this open source, just out of curiosity? Like, oh wow, cool. Excellent. So yeah, so it used to be, the entire API used to be like you subclass things, then Netflix gave it was like, it's just a decorator. I'm like, I can do that. So now it's just a decorator. So, but yeah, so how do our services talk to each other? That's a great question. So going, how do you go back like a million slides in this? Boom, this one. I know. It's just for me. No. So it says not involved. That's patently false. It is involved. It still has data in it that, so when I said we need to get data from a bunch of slow places, well, Django's not the slow place. Django's the fast place. We have other, but it's one of the places that we have to get data from. And we're actually just using our public API wrapper. So you can like pip install DISQUS. And it's basically a wrapper around our API, and I just monkey patch in, because it uses a JSON dictionary, or a Python dictionary, to define what those API endpoints look like. And then it gives you a very Pythonic way of accessing it, so you can say like discuss.user, or like discuss.posts. Like look at stuff. So it kind of looks like Django, but it's our public API. And so I just monkey patch that for private endpoints right now. So that's one way. So that's an HTTP based interface, and we're using this kind of simple wrapper around it. But that's kind of a pain because I don't think it's very scalable as a solution. But it does take care of authentication, which is cool too. So we use OAuth right now for authentication between servers, because I don't trust other services. They're made by people that aren't me. So we use OAuth to guard services, and we bless keys to say, oh, this key can access this data. And I think that that's a cool pattern, but it doesn't work super well with other maybe better ways of accessing data like zero RPC. I like event-driven data, so I really like queues. Previously at other jobs, I kind of found that most of the time that someone wanted data, other people want that data, so just put it on a topic and people can subscribe. The only time people were really using RPC to get data was at, oh, my service crashed, or it just came up for the first time. I need like 5 years of data, so like gather all this stuff from my local cache, but then I just want events. So I don't have a good answer yet for inter-service communication, but it's kind of like the next thing we're tackling. So, but I want to talk more about it, and we could have an open space on this later. Or I think there's open spaces this week. So, on Friday, is anyone interested in like a service-based open space? Like, sweet! I'll put one on the board.
Hi. I quite like the idea of using decorators instead of, say, overriding particular hook methods. It seems like it kind of avoids a lot of the, someone forgetting to do a super call, so you miss some of the superclass setup or something. I see that in setups and teardowns particularly. Do you have any kind of, is there a way of specifying ordering between those post-config?
That's a great question.
Or, I mean, maybe that doesn't come up, I don't know.
No, it definitely comes up, and the answer is no.
Oh, okay, right. So, yeah, I mean, it seems like, because that's kind of non-deterministic.
It's incredibly non-deterministic.
Right.
In fact, we should probably just put a shuffle in there to to make sure people don't rely on it.
Yeah, right.
No, it's a real problem, and I've been trying to think about a couple ways of doing this.
I've I've seen some stuff done with meta classes. If you look at, say, how SQL Alchemy builds its, what's the word? The parent class that you use to define a...
Sure.
Can't remember. One of those. Anyway, it keeps a little counter, so it actually things get ordered in the right way. That might be a solution.
Yeah, because so like one example is Redis is again used heavily in my ad server, and our ad server, DISQUS ad server. So it's used heavily, and most of the mixins want it. So I kind of had to patch in the Redis pre-config to happen as first, and then all the other configs, because everyone relies on it. Another option, what I did first, which I like more actually, is lazily load things. So each of these mixins should not rely on each other, right? They should be independent. So if there is something you need, like I need my Redis connection, make a lazy Redis connection. So look at Django.functional as a module, and I just copied that entire file and dumped it into DISQUS service because it's so useful to have lazy loading everything. It has lazy methods, lazy memoization, lazy... Does everyone know what I mean when I say lazy? So how many people? Raise your hands. We stop. Excellent. So yeah, so it's lazy loading everything, and that's how I kind of did it. Is I have a method that is lazy Redis initialization.
The other thing that I wanted to say was it seems like, I mean, maybe the pipeline example was a kind of toy example for the talk. It seems like everything that you wanted to do there would maybe be just as easily done with composition, and would kind of avoid some of the pitfalls that you might fall into where, say, you inherit from 2 compute services, for example.
Yeah, it could be. I like this method just because at the end of the day, it's like only a couple lines of code. So that was a toy example. My production code, there were much larger pipeline, more stages, more work done in each of them, but the testing it's still so, I don't know. We can talk more about this later though, as I think that there are many valid ways to kind of do a very similar thing. There's one in the middle here.
Hi, thanks for the talk first. As far as I understood, and as much as I know about DISQUS, you're using JSON pretty heavily for your APIs.
Yes.
And internal APIs as well.
Yeah, it's great.
So the question is, are you formally somehow defining the structure of the JSON blobs?
God, no.
No. Is that annoying? I mean, would you like to do that?
Oh my God, yes. So, yeah, there's one of the reasons that DISQUS service is not ready to be open sourced is that I mentioned this Q service, this Q mixin, and it's a companion package that we called Chatter, and it's protobuf encoded data over any queue, really. So it's a way for making schemas, composing schemas, writing that data to Kafka, Redis, Rabbit, whatever in memory, and using that to have a schema. Schemas are great, especially when you have a distributed system. They're even better. So I want them, but the thing is, JSON is this super awesome lowest common denominator, and like any language can read it, including JavaScript, which is something that we deal with quite frequently. So our front-end product is a JavaScript thing. So it loves that we just give it JavaScript raw or JSON. It's like, here's your blob, and so it's kind of this internal struggle where some systems want it and then others don't. So like another problem is we archive basically everything that happens in S3. And when you want to do Hive rollups or anything on that other data, again, JSON is a great lowest common denominator because like Hadoop and all these things speak it. So that's kind of why we use JSON, is that business guys can do their stuff with it, front-end guys can do their stuff with it, and it's good enough for the back end, but not ideal.
So there are schemas for JSON as well. I'll make an open session about that. That was annoying really for us as well, for our company.
Excellent.
So there's already the open session on board. So
I will check that out.
Okay, I think we have time for one last question. Nicola?
Sorry to be the smartass here. It's their job, but someone's got to do it. You wrote PDB set trace without underscore twice in your slides. It's still gonna stop your code cold, but in a different way.
Thank you very much.
So maybe one more, maybe.
I think there's one right back there.
Oh, could you
PDB that, etc. I'll update that before I put it online. Boom, boom,
okay,
boom.
thank you for the talk. It was great. I'm going to nitpick too, because in your mixins examples, you never use any super. And in your base mixin, you are rising not implemented. And that's two things that actually break multiple inheritance.
Oh, really? Ha. Yeah, no, I wrote this in Keynote, so I didn't have my linter.
Okay.
But you do what you do in order to get things to fit on the slides.
Okay, so that's not really from your code.
No,
Okay.
This is not really from my code.
Thank you.
Okay, so 4 minutes. So, if anybody wants to say anything more,
I want to say one more thing, actually.
Whoa.
No, I've got a microphone.
Okay, sorry, you're right.
I just want to, since this is a Python conference, one thing that I want to mention is how I write code on a daily basis. I use Sublime Text to allow people to use that. So Sublime Text 3 just got a public release, and there's this super awesome package called Sublime Python. It basically does code intelligence, it does linting. So if you're using Sublime 3, which you will all be using soon, I think. I'll let the Vim and Emacs people fight it out in the back. But everyone that's doing the Sublime thing, check out the Sublime Python package. It's going to make your lives easier. I'll add that as a slide if you see it on the internet. Cool.
Okay, so raise your hands again. No, one last question. Which one? Oh, down there.
Yeah,
somebody else who
right here
was
in the middle.
had
Someone raise their
no
hand.
question before.
What we use for make filtering? We use Python.
What do we use for what part?
What we use for make filtering
What?
in your project?
I'm sorry, I don't understand the question. Filtering.
Filtering
Filtering of what?
for message.
In the pipeline thing, it's this was just an example. So we don't really use anything to filter here. In the ad server, when we need to filter data, it is just we use Python, just because again everything's JSON, so we're just inspecting objects and making sure stuff is okay. But if I didn't fully answer your question, we can talk more after.
Okay, so if it's really a quick question,
We have literally 1 minute.
1 minute. You are too far away. It can't be so quick.
Okay, we have 1 vote for Vim.
Okay,
Let Mortal Kombat begin.
Okay, so thank you, Adam. Thank you very much.
Thank you.